Hello there. Welcome for more Haskell programming. Okay, so I was going to work on building out the API a little bit more. So I have the basics in place where I've been playing with servant and effectful and PostgreSQL simple. And I've been getting to the point where I have an API which will return a list of ledger entries, which is just reading from one table in the database. And I thought I would extend this and I would add another table, or maybe a couple more tables, but to start to add accounts as well, and then to associate ledger entries with accounts, and then you can say, give me the balance for this particular account, and it would fetch ledger entries and sum them up, and so on. That requires quite a lot of new SQL. So before I do that and spend all the time writing this in PostgreSQL simple, what I really want to do is have a look at an alternative SQL library for Haskell, a library called Haskell. It looks a little bit nicer in PostgreSQL simple. I have previously looked at what's it called, persistent and Esqueleto. But I'm not a big fan of the whole, I was going to say object relational mapping, but I guess it's record relational mapping. But the tying your data structure in your application to the data structure in the database, it doesn't, well, I can see the attraction of it, but I don't really like that approach. I'd much rather just occasionally write some SQL at the boundaries and then convert it back into the format I want it in my application. So that's why I went down the route of using PostgreSQL simple, but Haskell looks a little bit nicer. So I'm going to play with it a bit tonight, see if I can get it working and see if it really is any better. Okay, so in my application, actually, let me go back to main. When my application boots up, I have a load of old code sitting here, but anyway, we load the config and then we just call app.run, and that calls a function called app, which eventually calls server. But before it calls server, it calls this NT thing. And this is where we plug in the effect. So we have an effect which is run ledger store IO. And we've set up here that the effect needs to be ledger store, which is this thing, which needs to implement load ledger and create ledger entry. And then we got an implementation of this for run ledger store IO, where we're calling load from DB, and this is using the connection pool in the config, and it is using PostgreSQL simple to run a query. So my thinking is that I'm going to try and replace this by writing something in the database layer which implements maybe load from DB or some implementation of loading the ledger and some implementation of creating entries in the ledger, and then write a new implementation of this effect. So there'll be something like run ledger store SQL, which will call those things. That's the plan. So to get started, I'm going to do a couple of things. One is I'm going to install Haskell. Where is it gone? Here. Let me just duplicate that tab for a second. So I'm going to kick off the installation of Haskell because it might take a while. So I want to go version 1.8, and there are a couple of libraries I want. Can we go back again? Not quite. Let me search Haskell. Maybe it's listed in the README actually. There are a couple of things I want. I want Haskell, the basic library. I also want template Haskell version of it because it looks like it's going to save a lot of time. And then later on, I'll have a look at the migration and the pool stuff as well. Okay, but I can at least start with Haskell 1.8. It's the library. It's the library. Yeah. So we want Haskell, and it was 1.8. And Haskell th, and that was 1.8 as well. Okay, so save it. Hopefully it can install those. get going. The other thing I'm going to do is I'm going to try. Oh, it didn't work. It's errored on something. Let me see what's erroring on. Get result dependencies. Oh, I've got the version of Haskell TH. That's obviously a lot lower. 04022. Okay. Was it 04022? Let's see if that works. Oh, it looks happier. Okay, while it's installing. I was thinking about structuring these things a little bit better. I was thinking about creating an effects folder where I store the code that defines the effect and wraps the underlying library in some kind of effect, but maybe also have maybe a directory for database related code. Maybe, not quite sure about that. Actually, I don't really like structuring things by their implementation details, so I don't like having, database slash, in this case, ledger. I'd much rather have ledger slash database. So maybe I'll structure it that way. So you have something like ledger DB, and then later on I'll have an effect. I want the effects to live together, so maybe all database code should live together. I don't really know. I'm just going to oscillate if I don't make a decision quickly. So let's go DB ledger to start with, and I'll put my it'll be db.ledger in this level. I'll put my new Haskell code inside there. So it'll be under source, DB, and ledger. It did not do the right thing. Okay, I hate it when it does that. Touch, source, DB. Oh, I need to make a directory first. Create that, and then touch, source, DB, and ledger.hs. Okay, so it also failed here because of something. So, oh, it's because I saved it partway through running, I think. Try running build again, see if it's happier. Yes, I think that's right. Okay, so ledger.hs, there we go, this new thing. Okay, look at that. So in here, I'm going to put the new code which uses Haskell to connect to the database and to do some stuff. So let's go and copy some stuff from the internet. There is an example here. I don't massively want to grab all of this because where's our example? Some statement. Okay. Oh, 1 second. It's annoying. I thought I was going to sneeze and I didn't, and maybe I'm going to in a second. Anyway, right. You write these statements, which are of type statement, and then some types. So statements parameterized over input and output types. We have the SQL part. The statement's got the SQL part, which has got placeholders, and then it's got these complicated things for taking its input values and turning them into int8s in this case. and then this decoder to take the result value and turn it into an int64. Very ugly. Same thing with template Haskell, much nicer, I think. So again, you have the same signature, but now you're saying select this stuff, and it writes the rest of the code for you. And I think that just looks like it's worth doing. Don't know what singleton statement means yet, but we'll get there, I think. Okay. So sorry, the other stuff I'm going to need at some point is I'm going to need a connection. I'm going to need to run in the session. I need to run this code effectively using the connection, and then look at the result. The other thing I like about its library incidentally is that it doesn't throw exceptions, it returns an either type, which I think is going to be a little bit easier to work with, or at least clearer whether or not I'm handling the exception properly. Okay, so what are we going to do in here? I'm going to copy this code for a second. But I'm then going to comment it out because I want to grab bits of it, but not all of it. And I'm not running it inside main. So I'm going to write something that will create a session and return it. Or connection and return it. Right, let's do that. So let's say something like connection is going to return IO of either whatever this error is, I'm not quite sure what this is, or a connection object. Connection object, connection value. And it's going to be, actually, I think I want to take the config in here and return that. So given some config, let me just import config for a second. Or even for a second, just import it. If we quickly look inside config, we have got DB connection, which is a byte string, and idle time and pool size. So we have the connection in here. I'm going to need access to the constructors inside here. And I want to say, what we really want to do is call connection dot acquire, and then we get the settings. And the connection settings use connection.settings, but there was a different way of doing this that I found. Let me go back to here because I want to find, no, it's not really what I want. I want to go back to package, I think, so I can have a look at this. So acquire takes settings, that's really handy. All settings encoded in a single byte string according to the PostgreSQL format. I might actually have that because settings here takes a host, a port, user, password, database, and returns PostgreSQL settings byte string. I think that's what I already have in my config. So here I can say config dot what was it called? Config.db connection. best name for it. Okay, so can we import this? Yes. Can we import require? Okay, so the thing it can return is a connection error. Okay, that should be enough for us to connect. In theory, we won't use connection yet, but it should give us a connection. So if we go back to main and restart the LSP because it got unhappy when Caval got out of sync. We have the config, and before we call api.run, we want to say Haskell connection. This comes from calling ledger.connect. Connection. For DB ledger's ledger. I'm going to pass in config at this point. And I'll just print out the Haskell connection. The implement show. Does it implement show? Printing isn't going to work very well. Let's try printing it. No show instance for the connection. Okay. Then let's just say case Haskell connection of, and if it's left error, then can we print out the error? Apparently yes. And if it's right, whatever, we'll just say bootstrap connected via Haskell. Okay, and back to here and just say Cabal run. Oops, Cabal run pay me. No, that. Okay, I don't have the environment variable, so the config is not loading, so I can source this thing. Okay, so it said it connected. Right, I imagine it hasn't done any connection yet, but at least it says it has connected. So that's a good start, I guess. So we have our connection. It doesn't really belong to the ledger, so maybe I should move this, but I can move it when we get it working. Okay, next thing I want to do is create a statement which doesn't do very much. So we could just do something like the sum statement. Actually, let's do something with it. So ledger list statement. And now it's not going to take any arguments. It's going to return a statement. And to interpret this, I'm not actually going to look it up by any parameters at all, but I'm going to return a list of ledger entries. Okay, I can get rid of this code now because actually I don't need very much. I'll need the session running stuff, but that's probably that can come later, I think. So list statement. In their example, they have this thing. Do I need some extension? Let me just try import sql.th as th qualified th. Still does not like this, so let's look for language extensions they're using. What are the strings and quasi quotes? It's probably quasi quotes I'm missing. Got the whole thing because it's easier than typing it. Probably the strings are still going to be running. Okay. I think that's better. So it's not, it cannot match the expected type. So we're going to say select, and I guess it's going to be what's in this table. So ID, amount, and date time. So maybe we could try just grabbing ID. So we're going to select ID from ledger entries, and that's going to be, I don't think I want single and statement instantly. It just feels like that's going to return a single row. Can we go back? No. Can we find th? So that's a maybe. It's not really what I want. This looks closer to what I want. Let's grab this example. And then I can try and make it work. So my list statement is not currently going to take any arguments. I don't have their type. I'm just leaving it place for seconds to the to control the errors, I guess. Okay, so it's gonna be, oops, sorry, I already have a bit of this I want to change. So list statement. What's our time up doing? Legal case, unload the case for a second. Oh, it's not going to show me the pop-up for DIMAP. That's quite annoying. So maybe statement. I can say th.maybe statement. I will show me the type for DIMAP. It will not. Quite annoying. Okay, so they're taking the input user ID and unwrapping it to get the I guess they're unwrapping it so that they can use it in their query. So what I want to do, I think, is say select ID, which is of type UID, and what else was in here? Amount, which should be like an int. 32. They have for ints. They did it all as text. Okay, amount. Oops. I'm going to select int 32. We won't have that. Select that from user. Now not give me a type. It will not give me a type of DIMAP. It's quite annoying. So let me just, for a second, show ID in there. I'm not doing anything with the input. No code exists for type int32. Int? Right. So where is their DIMAP coming from? It's coming from profunctors package. Okay. They can reduced DIMAP course. Nah, let's not go there quite yet. I don't mind looking at what comes back from the database. The thing is, though, I don't really want a maybe statement. I want to grab a whole bunch of stuff. So I want to see how that works as well. So just have a quick look at what functions we have in here. That's fetching a single row. I don't really care about nulls yet. So single statement is a statement producing exactly one result row. It's not what I want. Statement choosing one row or none. Again, not what I want. Vector of rows. I don't feel like I want a vector, but maybe I do. Function from fold over rows to the statement producing the result of folding. Nope. Row ignore statements. Nope. This looks like the most likely one. Let me just take limit 1 on here, and then I can change this to singleton. So we get a singleton back. Okay, and the type here is a tuple of ID and int32. And we want to turn it into a ledger entry. So we might as well grab the other field then. So it's date time, which is of type. Did it have a date time type? Someone gave me a list of all the types. No. Oh, here. Sorry, these are the types. I guess this is probably the closest. Let's try that. Oops. So we should get those three things back. And what we now want to do is map them into ledger entries. So to ledger entry of this thing. And this is going to go from UID int32 and UTC time to a ledger entry. There I go. What other types we have? We had bool, these ints, numeric. So I guess the int32 is what I want. But it's not quite the right type, so I'll have to coerce it. Okay. So this is our tuple. We got UID, amount, and date time. And we're going to return a ledger entry. Why does it think it's going to return a list of them? I think it's going to return a single one. So we're going to return a ledger entry. I need to import the constructor for this. Ledger entry with UID, amount, and the date time, and then some of the types were wrong. So it wanted int 64 but got an int 32. That's okay, we can do that. So it was int 8. And this is int 64. Give it that one. Still not right. So this returns what's a singleton statement? Ah, of course. Right, so I will start by doing this, and then I can look at a vector statement, see if that will get me multiple entries back. Okay, so this is my statement. Quite nice, I'm just writing SQL more or less with a little bit of type information. And then I got something which takes the tuple that it gives me back and turns it into my domain object. And then I can say list, which is going to do the session thing. So I have no scroll bar, so I can't scroll this way. Here we go. Yeah, so session abstraction over Dave's connection, all possible errors. It's going to take my input types and give me back a session of the result. So let me call it list session, seems to be the naming. And we don't have any input data here at the minute, so it's just going to return a session of list of ledger entries. It's a list session is so is that just session.statement? It doesn't take any input. And the statement I'm going to run is my list statement. And that might be it. So we'll import that, and then we'll import it again, but qualified. Okay. And list, finally, should go from no arguments to IO of, actually, I don't know why I copied that because I don't know what it is. It's going to be either some type, which I don't know what it is yet, or it's going to be a list of ledger entries. So list is equal to, and then we need to take our connection. So actually, I'm going to say it needs to take a connection. And then it will do its thing. And then we can say, we have this, so it'll be session.run. This session, which is list session, doesn't take any arguments here. And the connection. And it can't map A with session.session error. Okay, then I can just reduce that. So in theory, from main, I should be able to call connection, and I should be able to call list, and it should give me back a list of a single ledger entry. Okay, so we get an error, we're going to bail on it, but otherwise if we have a connection, we're going to say ledger.list, just stick a do in here. No, I'll stick an odd, let's stick a do. And I can say the result of running this. So let's take the connection, and I can say case result of, and then left error. We just print it out, and right of ledger entries. I'll also print those out. Okay. I can write that in a nicer way, but it's not worth it because I'm just trying to see if it works at all. So we should get a single ledger entry printed out. There we go, okay. I won't bother doing that yet. So I can now connect to the database and run a query and get some data back. Good start. So what does a vector statement give me back, and can I map over it? Okay, so it gives me back a vector of UID in64 and UTC time. Does it? No. It gives me a result of those things. Okay. So I'm actually mapping over this result type rather than mapping over the thing inside it. So what do I know about the result type? Not from there, maybe from here. Open a new tab, and then I should go to package, and then look at, let me look at our example again. So I'm look inside statement, I think. So statement parameter result. That's what I'm looking for. Okay, so I really want a row list. I think I don't want a vector. But it's still packed into this result. And I want to go from result of A to the A. I want to get the thing inside it. But I do recommend row vectors. Let's try and work out how to do that. Okay, so can I say let result of res equal that in, and then what we want to do, we want to say we want to map to ledger entry over result. Where does result come from? Haskell decoders, but presumably also in Haskell. It's not suggesting any import for it. No. Is it exported? Haskell decoders all. It's a hidden module inside there. Okay, so I'm going the wrong way about it. It's quite annoying. It's like I want to fmap, that. No. It's like I want to do that. So, type of res is a vector of, this says here it's a vector of this tuple. Vector of that tuple. So can I not then fmap over the vector? Data vector. Instances. Functor. Also it's reversible. So I should just be able to map over it. Okay, so I take to ledger entry. Oh, hang on a minute. That's wrong. I didn't want to do that anyway. Right, okay. Now I want my double F mapping, I think. Because the type of res should be relevant types. Come on. Oh, it was higher up. The type of this really has been passed in as a vector. Cannot import data vector. Is it hidden? Qualify that as vector. And I need to unhide this. Vector 013 01310. Zero 1310. So it's ledger entries. Just import that. Do vector vector. Okay, so it's now a vector. These things. No, we're importing it here. Import constructor as well. Oh, no. We got B and we want to fmap UID amount date time to that. And this is going to return a list of ledger entries. And we're going to map it with B. Okay, let's do that instead. Let's get rid of the fmap here. Couldn't match type vector with list. Okay, so this is going to give me back a vector of ledger entries. Okay, and then we want to say something like vector dot to list of that. Okay, no, I expect something that. Okay. Yeah, so it's going to be hero of that. I don't want to be doing this, so, but same vector. Okay, that's confused me now. I'm going to go to the pures. I think the pures made things bad. So we have res, right, which is a statement. Maybe we should use die map. So in their example, up here using die-map, I don't want I don't want any of the input. What's the type of die-map? So given A to B and C to D, given something like a function that takes a B and returns a C, turn it into a function which takes an A. Right? Yeah, given some example of this. I can't read a thing about proof functors. It's a bifactor where the first argument is contravariant and the second argument is covariant. First argument is contravariant. The way they're using it here so this is their A to B. They're saying, given the user ID, unpack it into an A. Okay. Oh, I see. Okay, so maybe. So given this thing returns a statement which takes an A, and they're returning a new statement which takes a user ID, and using this to turn it into an A. And it returns a C, so they're creating a map from C to D. So the return statement which doesn't return this tuple, it returns maybe this thing. Okay, but I'm using a vector. So what I would want is something which is weird. I have to use die-map. I could let me grab proof functor and then I can use rmap. So proof functors 551. Was it 551? Install, and I'm going to say rmap, and I just give the mapping of the result. So we just can say rmap, and then to ledger entries. Back to vector for a second. And then this statement. Did I get something wrong? Compile build. Will it even install the package for me? No. Uh, 562. Whoops. Don't print that. Pro functors 5.6.2. Will that build? Yes, it will. Okay. Restart the LSP. Did a proof functor that. Okay, cool. So if I wanted to return a list of ledger entries, so a vector of ledger entries, that should work, but other things should break. Okay. So I want to return a list, because who cares about performance, right? We should be able to say vector.toList of that. Not quite. There we go. Okay. So in theory, it should be running this statement and then mapping the vector it gets back into a vector of ledger entries. I can see if it works, first of all. So what we expect to print out, if it works, is a list of 3 or 4 ledger entries. Can't remember how many there are. Compile, run that. And it prints out a single ledger entry, which is not what I wanted. Okay. First of all, can I do this? So I'm going to turn this back into mapping a single thing. So a single tuple into ledger entry. And can I rename it? Probably not, actually. But I can say to ledger entry. So what I want to do is I want to take some vector. I can call to ledger entry map towards that vector. I'm going to turn it to list. I'm going to drop the limit 1 because that was probably what the mistake was. Go back to here and run it. Okay, at least we're right. So we're getting a few of these things back. I could return them as a vector, but I think I might leave it as a list for now because that's what the current interface is. Okay, so I have the basics of Haskell where I can connect to the database. I'm going to move that into its own function, I guess. Move it into a module probably. We've got the ledger stuff. So we'll get database connection. I want to look at pooling that. So we replace the config pool. Where did we use the pool? Oh, I think we used it in here. No? Where's this called from? Okay, when you... This is a bit weird actually. When you load from the DB, at that point it creates a pool. That's not right. So I'm going to... what am I going to do? I don't really know, but I'm going to create a pool early on. So I'm going to pull out the connection pooling stuff, put it somewhere. And then take this list, add a create function as well, a create statement. And then I want to wrap it up so it becomes an effect that I can pass in as a ledger store. But I'm kind of out of time tonight, so I'm going to look at that next week. But at least I've made a start with Haskell. I got to the point where I can run a statement which gets some data out of the database, which I guess is kind of cool for an hour or so. Cool. All right then. Thanks for watching along. I hope you come back next week, and I will continue with Haskell and wrapping it up inside Effectful. Hopefully see you then. Goodbye.